Today I am going to talk about some vector properties which we can use in advanced level mathematics paper. We can represent vector by a line segment. As an example, I draw a straight line and arrowhead on it. Magnitude of vector represented by the length of line and arrowhead shows the direction. Magnitude of the vector we call it as modulus of vector also. When we multiply vector by a constant, we can get two types of vectors. First one is we can get new vector on given vector, and second one is new vector parallel to given vector. Magnitude of this new vector depend on the constant that we multiply. When we talking about the addition of two vectors, there is a law to add two vectors. We call this a triangle law of vector addition. Let's see what is the triangle law of vector addition. When two vectors are represented as two sides of the triangle with the order of magnitude and direction, then the third side of the triangle represents the magnitude and direction of the resultant vector. As shown in the figure, you can see I draw a vector A and vector B as two sides of the triangle, and the addition of these two vectors A and B are given by the third side of this vector. Direction is from beginning point to the end point. When we are talking about subtraction, there is no such a thing as vector subtraction. Let's consider vector A minus vector B. Actually, this is an addition as below. Vector A plus negative vector B. When vector is multiplied by negative 1, only its direction turn opposite. So we can use triangle law to add these two vectors. By multiplying 1, the direction of vector turn opposite. Condition to equal two vectors. When we talk about equals of two vectors, there is three conditions. First one is length of two lines which represent the vectors must equal. Second one is two lines must be parallel. Third one is directions of vectors must equal. As you can see in the figure, I have drawn two lines which have equal length and they are both parallel. And the direction, we know that direction show by the arrowhead. Arrowhead is towards the same direction. So the direction of vectors must equal. Then I can say vector A equals vector B. When we represent the location of a point relative to origin, we call it as position vector of that point. As an example, this diagram shows the position vector of P. Here is the point P and the position from O. This vector we called as position vector. Diagram shows the position vector of point P. It can denote as OP and the arrowhead. Arrowhead shows the direction. So, if we denote any point relative to the origin, we can call it as a position vector. Then we are going to talk about the unit vector. Vector whose magnitude is 1 called as a unique vector. If A is a unique vector, then modulus of A or magnitude of A equal to 1. If A is a given non-zero vector and u is a unit vector in same direction, we can write equation for a unit vector as b. Unit vector equals given vector divided by its magnitude. This is valid for any vector, and we can find unit vector along the same direction. Now we are going to talk about unit vectors in x direction and y direction. Unit vector in x direction is denoted by simple I, and unit vector in y direction is denoted by j. Magnitude of vector given by terms of I and j can find as b. I take example. I denote c vector as ai plus bj. The a and b are real numbers in this situation. Then I can find the magnitude of this c vector as this. Modulus of c equals a squared plus b squared square root. This can be applied to the when the vector is given by I and j terms. So magnitude equal to square root of a squared plus b squared. Then we are going to talk about angle between two vectors. Angle between two vectors important when we are applying dot product. We are going to talk about dot product next. This angle is very important when we using dot product. Angle between two vectors are defined as this. The vectors must come towards the same point. Then the angle between these two vectors theta in here called as angle between two vectors. Or otherwise vectors must go outward from same point. Then the angle between two vectors can called as theta. The third situation, you can see a vector is going outward and b vector is come towards the intersection point. In this situation, we can extend the b vector. Then, as you can see, we can take angle between two vectors marked in this. So after expand b vector, we can see both extended b vector and a vectors are going outward from the intersection point. In this situation, we can expand the vector a. Then you can see expand vector a and b vector come towards the same intersection point. The angle between two vectors can denote as theta. So when solving problem, you must consider, you must to get correct value for the angle between two vectors. When I am going to introduce you dot product, this product is called as scalar product. When we use this product, we get the scalar. That is why we call this as a scalar product. So here a and b are two vectors. Then a dot b is called as dot product. It is equal to modulus a times modulus b into cos theta. Here theta denotes the angle between two vectors. Now I am going to apply this dot product to unit vectors I and j. First I apply to the I. So I dot I equals modulus I into modulus I into cos theta. So I am considering the same unit vector. So there is no angle between I from I to I. So the angle is 0. So we know that the magnitude of unit vector is 1. So I can get 1 into 1. Cos 0 is 1. So the I can write I dot I as 1. Same goes to the j. J dot j equals modulus j cos 0. Then 1 into 1 into 1. Then j dot j equals 1. Now I am going to apply to the I dot j. So then I can write it as I modulus I into modulus j into cos phi by 2. So we know that I is the unit vector in x direction and j is unit vector in y direction. So the angle between these two vectors are 90 degrees or radian 5 by 2. So I use theta as 5 by 2. Then I substitute values 1 into 1 into, we know that cos 5 by 2 is 0. So I dot j value becomes 0. And finally, I am going to show you how to apply dot product to normal vector. Here I am take a vector A, which is non-zero vector, and this is not a unique vector. This have some value. So I can write it as vector A into dot vector A equals modulus A modulus A. So angle, we know that we can't measure angle to same vector. So the angle is 0. So cos 0. Then I can write modulus as vector A into vector A dot vector A equals modulus A square. This is the basic of vectors what we need to solve the advanced level vector problem. In next video I am going to talk about past paper question, how to solve them and what are the easy way to solve the vector problems. See you in next video.